Greetings, folks. This is your Mr. Zimba, and today we are looking at uh, a question. This is Science Paper 1 and Science Paper 1 under the ECZ curriculum. This is the physics. Those of you who are watching us for the very first time, make sure that you subscribe, share, and like our video. Right. So, folks, this is a very interesting question under atomic physics. This is a topic which it's a must understand and must know even as we prepare for the exams. This is atomic physics and this is radioactivity. So, colleagues, we need to make sure that we understand fully this topic. All right. Then, looking at our question there, they're saying figure B9 shows a deflection produced when radioactive radiation passes through an electric field. Okay, so this is our, so we have the radioactive source, we have lead box, and we have these other three radiations. All right, so now you need to understand that the 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 radioactivity. What is this radioactivity to start with? What is this radioactivity? So the radioactivity is just the emission of radiation. Radioactivity is just the emission of radiation. And these radiations can be emitted in three ways. That's why we have three types of radiations. It can either be the alpha radiation, or rather the alpha particle, the beta particle or beta emission, and also we have the gamma emission. So that is the three types of radiation that we need to understand. You need also to understand that when you look at beta emissions, beta emission, they are naturally fast moving electrons, beta emission. And you and I, we know that electrons, they possess a negative charge. You look at alpha particles. Alpha particles, they are helium in nature. They are helium in nature and they possess a positive charge. Then the gamma radiation does not possess any charge. So just by looking at our structure here, we are able to see what is happening and we are able to identify the types of radiations which are involved. Identify the radiations represented by the letters A, B, and C. So we can see this one, it has a positive charge. So the one with a positive charge is what? This is an alpha radiation or alpha particle. This is an alpha particle or an alpha radiation because it has given us a positive charge. There we can see it has a positive charge. This one has no charge. So this one has to be what? Gamma. So this is gamma radiation. It has no charge. It does not deflect in an electric field. So gamma radiation does not deflect, but the alpha particle will deflect. If this is gamma and this is alpha, this one becomes a what? This is a beta. So this is a beta particle or a beta emission. Remember, I said beta emission, these are fast moving electrons. And electrons, they possess a negative charge. That's why we are saying this is a beta particle because of the charge. So you have to understand the charge that these three emissions have. All right, so let's proceed. Which of the radiations A, B, or C would be most suitable to prolong the shelf life of tomatoes? Okay, the one which can prolong the life of tomatoes here is the gamma. This is the gamma, or you say the B radiation. So this is the gamma. It's the one that can prolong. This is talking about preservation. Gamma can preserve the life of tomatoes. Gamma rays, because they are able to penetrate. These they can deflect. Gamma rays, they are able to penetrate and prolong the life of tomatoes. Right. See, we have, I'm sure that is cobalt, but it's an isotope. So this one, this element there they have given us is a B emitter, okay, with a half-life. Okay, so they have given us half-life, and since they have given us half-life, I'm sure where we are going, we'll be able to use this same half-life. All right. Uh, Roman numeral 1. What is the nature of the beta emission? What is the nature of the beta emission? Remember what I said. These are simply fast moving electrons by nature. So these are, so the beta particles or beta emissions, these are fast moving electrons. So these are fast moving electrons. Remember I said electrons, they possess a negative charge. That's why even here, where we saw a negative charge, we said these are beta particles. Right. What is the proton number and the nucleon number? Okay. So how do we find the proton number and the nucleon number? Right. So this is the original compound that they have given us. Okay. Okay. So this is the cobalt they have given us. So now they want us to uh, write the nucleon number, which is known as the mass number, and also we write the proton number after emitting a beta emission. Okay, so when these emits a beta emissions, what happens? So the mass number remains the same. So the mass number remains the same. Okay, the mass number remains the same, but the atomic number will increase by 1. Then we have what? We have 28. Okay, we have 28. So this atomic number or the proton number will increase by 1, but the mass number or rather the nucleon number remains the same. All right. So the nucleon number has increased by what? By nothing. This one has increased by 1, and this one, it's an electron. So after doing this emission, want us now to write the nucleon number, and also we write what? The proton number. Okay. So what is our nucleon number? Nucleon number is just 60. Hope we are following each other. If at all you don't understand this topic, you can just reach us to us on this contact here, so that we can explain further on this topic, because this is a very, very important topic, and this is a topic that will give us 3 marks in an exam. Topics like radioactivity, atomic physics. This atomic physics does not miss in an exam. So we are emphasizing that make sure we understand this topic. All right. So we have said the nucleon number is this one. So in case we didn't know, the nucleon number is just the sum of the neutron number and the proton number in the nucleus of an atom. That's what makes it the nucleon number, which is also known as the mass number. Okay, so this is our nucleon number, 60. It has not changed anything. Then the proton number has increased by 1. So this is our total number, which is 28. Let's proceed. Calculate the time required for the activity of a freshly prepared sample of that cobalt to fall to that number there. Okay, to fall to what? Fall to this number they have given us. Okay, so how do we solve this? So there are two ways on how we can solve this. Don't make your life difficult, ladies and gentlemen. So what we are going to do is, uh, this is the final. This is the final. This is the initial. So we are going to multiply 1 by half. Then we're going to multiply half by half, which is 4. And then by half, this will be 1 over 8. Again by half, uh, this will be 1 over 16. Then by half again, this will be 1 over 32. Okay, so this is our 32. All right. So how many half-lives have passed here? So we have 1, 2, 3, 4, 5, right? So we have 5 half-lives. 5 half-lives multiplied by what? By the number, the period, which is the years, which they gave us here, 5. So 5 multiplied by 5, this is what? This is 25. So that is uh, the the answer that we are supposed to give there. So don't make your life difficult. Or maybe if you don't understand this one, you can still use the other one where we are going to say, okay, so time is equals to number of half-life and the period. Number of half-lives, how many? 1, 2, 3, 4, 5, 5 multiplied by 5, giving us what? 25. So that is the answer. This is the answer. This is the time required for. This is 25. This is the time that is required. So in case you still have challenges with physics, chemistry, biology, make sure that you reach us on this contact number here for any sciences and mathematics. But please, as you prepare your exams, understand the atomic physics, understand the half-life calculations, understand the emissions, understand why particles they undergo these processes, the instability of the nuclear, understand the nuclear fission, understand the nuclear fusion. When you see fusion, always remember biology, because fusion is splitting. So fission is splitting, fusion is joining. In case they ask you to define this, define nuclear fusion, define nuclear fission. So fusion is just joining, joining to form a large sample, joining small sample to form a large sample. That is fusion. Fission is just you split, you disintegrate, you split the nuclear, you disintegrate them. So thank you so much for watching. Make sure you subscribe to our channel.